Bittlingmayer worked for Google until he decided that it's time to switch from making machine translation to verify what Google is doing. And Adam will tell us a little bit about his work, and he's also a regular speaker at DataFest, so please welcome Adam.
So, good to see everybody. Yeah, so today we'll be talking about scaling human quality translation. Human quality is very important in the real world. So I'm not a theory guy, or I don't care about the inner workings of the models too much. This is really about making how we roll this out to the real world and some of the lessons that we've learned from that, which do have a lot of implications for ML. Yeah, and so the subtitle here is building verification for the original generative task, and that being translation. So I'm going to try to go short and leave lots of time for Q&A, and happy to talk to folks after the talk as well about more details. Yeah, it's all good. Yeah, so when we say verification, we basically mean just good or bad for each translation. And so what we're going to cover today is sort of the difference between generation and verification, and sort of why I quit working on generation and started working on verification. The accuracy requirements that are needed for this task. A little bit of an overview of prod systems from the real world. A little bit about the models. And then open problems. We've solved a lot, but there's a lot more to solve. And then we'll have some time for Q&A. So firstly, about generation versus verification. So as all of you know, generation basically, I don't want to say started, but the transformer-based models at the heart of Gen AI started in translation in my old team at Google, at full disclosure, right? And so that happened in 2017, right? And translation was the, if you say outside of AI, but like in an agency, if you go to that Bagram Dropmek, right? It was the first job where there was, something like these models available, and people started working not from scratch, but on editing the output of AI. And that already started at Sun in Silicon Valley in the early 2000s. But really in like the mid 2010s, just swept it. Everybody switched from, writing translations from scratch to just editing the output of Google Translate or DeepL or whatever. And so yeah, this became the new workflow. You have generation and then humans. Very simple, right? So the question is, how much faster was this post-editing, right? I mean, instead of having to do something from scratch, it's already generated for you. Previously, it had cost about $1 a sentence, 10 cents a word, right? Give or take. Anybody have a guess about how much faster things got with this new workflow? That's right, it remained the same. So better generation alone, if I go by dollars, which is what I care about if I'm buying a million translations, right? Better generation alone, it helped in a lot of cases, but for human quality translation, for high value content, it basically failed to do anything. So like when, 10 years ago when I could finally sort of leave Silicon Valley more and start going around Europe, you talk to like a taxi driver, they're super happy with Google Translate because their alternative before that was no translation. And I'm very proud of that, and I make no apologies for having been a small part of that, right? But if you go to human quality translation for high value content, right, you say like, the things that all of us care about and that why we're having this talk in English, latest papers about ML, whatever, that's not even available in German. In Armenian, you can forget it, right? And the reason is because we didn't see any revolution. This is stagnation. This is like basically the same thing where we're still flying in a Boeing that's made in the 1970s, but for translation. We made no progress. It was like pushing on a string. And this is, you know, and I had to kind of like accept this as somebody who had been working on the generation side. And the reason is that if humans need to verify every single translation, it takes them roughly about the same time. It's not faster, even if they don't edit many of the sentences. So even if you don't edit a sentence, it's the checking, it's the cognition that takes the time, and the time is already lost, right? You can say, yeah, it makes me faster, but if I say, oh really, here's a million sentences to translate, you'll say, wait a minute, right? So that's the reality, and not all tasks are like this, right? If I can generate an image and I can say, yeah, that's good or not, that's a million times faster for me than having to create that image with my hands. But translation is like that. For a professional translator, they're really fast at the typing, at the thinking, et cetera, and it doesn't really change it for them. So verification is used to skip manual work for sentences that humans would verify unedited anyway, right? So if you look in these workflows, many sentences require an edit. That's why they have to go to humans. But for another chunk of sentences, maybe half, depends on the content, they are looking at them, spending time on them, et cetera, and approving them unedited. And so with verification, the goal is to find those sentences and to automatically approve a good chunk of them. So verification is very valuable but hard, right? If you look at generation, you almost just see people just keep undercutting each other. It's getting cheaper and cheaper and cheaper and cheaper, and you know, it's so cheap that even for us engineers, it's actually hard to like how many cents per word is Google Translate or ChatGPT? It's so many zeros in there. Verification is not like that, because if you verify something, that means that you can actually skip human work, right? If you just generate something but nobody knows how good it is, now I got to look at this. It cost me money. But if you verify something, now you've actually replaced human work. And so it's very valuable, but it's very hard. So it's so valuable that like Google, Amazon, Microsoft, et cetera, worked on it, but it's so hard that they all failed at it, right? So I was at a research conference in 2022, you know, my old team at Google said, hey, we're working on something, also working on quality prediction like ModelFront, right? Great, guys. Same thing with these other companies. Some had started earlier, some had started later, but it never really panned out, and I think it's very interesting to think about why, but that's the fact, right? And so what I'm kind of doing here today is saying, okay, well, you know, at this point, ModelFront has made it work in the real world. Companies that you know, that make products that you guys use, that you maybe even work for, et cetera, have relied on ModelFront for hundreds of millions of translations, of words of translation. And so, you know, at this point, after sort of 2 years heads down working, getting those off the ground, we can come back and share a little bit of lessons that we've learned along the way. Yeah, so at this point, it's used for millions of words of valuable content, and it tends to be, again, it's not like low value content. It tends to be stuff like technical docs, right, where there is a value to having quality. You can't just make mistakes. I want to emphasize very much that you know, models are a little bit of a commodity. It's really about systems. And so I take a lot of inspiration from Waymo. Personally, I'm very frustrated with a lot of the way that, you know, Google has, I still believe, probably the most AI talent of any company, and certain areas that have the most density of talent, and obviously other great companies right now, right? But I'm very sort of, in some sense, disappointed with what they've done with it. But Waymo, which is also part of Google, is I think one of the awesome, indisputable success stories of the last few years. You can go to San Francisco when I'm there. I take it. It's fast. It works. It's safe. It's probably safer than humans, right? So Waymo is like, but it's very real world, right? It's a very real world problem. All theory falls apart when this thing could kill somebody. And so I definitely encourage you to think about Waymo, not Kaggle, and personally I cannot contribute anything to anything that's sort of Kaggle-like. I can only share stuff that's more Waymo-like. Yeah, so regarding the accuracy requirements, again, more from the Waymo perspective, the accuracy requirement is very high here. So verification, since what you're doing is saying if something good is good or not, it's only valuable if it works. Generation, if you generate something where it's right 80% of the time, that's useful. Verification is not like that. The whole point is to be right. And so it's only valuable if you keep the human quality. Otherwise, we're back to Google Translate. So human quality is not perfect, but it's a very, very high bar, and it makes maybe different types of mistakes than machines make. And concretely here, we're talking about more or less than 1% edit distance between what it would be if a human were doing all this work and what it would be if you're in the picture. So that's a very, very high bar. It means basically 99% of characters need to be exactly the same between the final output of this new workflow and the final output of the old workflow. And like in medicine, you can be wrong in one direction but not in the other. It's okay to say a translation was bad when it wasn't really bad. You know, we don't want to do that too much, but it's okay. But what you don't want to do is let bad translations through. And like in self-driving, you're going to be under more scrutiny than humans because, right, you know, there's some idea that humans are perfect. But if you're saying, okay, we're going to let a robot do this, you basically have to fully submit to airport security, right? And just totally transparent. So now we'll do a little bit of a prod systems overview. We basically work inside of these legacy systems where people have always been doing the work. That's very important because they have those systems. They don't want to change, right? That would be it's kind of like you had to make Waymo work on the real roads. There was this idea kicking around Silicon Valley like 10, 20 years ago when, you know, self-driving wasn't working. Like, oh, if we could change the road signs to make them easier and like kick the human drivers off the road and all this stuff. I think there's always a Russian saying. Do you know which one is coming to mind now? So, right, it's like, change the problem because my model's not good enough. And that's, you can't do that here. You just got to make it work in the real world, in these legacy systems, et cetera, et cetera. But if you kind of get that out of the equation, what you see here is just, I would almost say like a very standard human-in-the-loop workflow, right? So first you generate, then you verify. If you can skip humans, you skip them. If you can't, you still go to humans, right? I don't think this is any different than, let's say, fraud at the ATM, where some things get alerted, they go to humans, and some things don't, right? The thing, though, that I mentioned is you have to have monitoring, right? We have to have some way of knowing that this stuff is keeping the quality. So we have to have monitoring, and we also have to have retraining, of course. So for that, we need a feedback loop. And of course, we have another problem that all of this stuff is now getting approved, so we don't have any feedback on it. So you need some kind of holdback, some kind of, you know, measure of stuff that the model would approve that still goes to humans to keep getting that signal. So this is basically as deep as we're going to go here. I'm trying to make complicated things simple, not simple things complicated. You can call it human in the loop, though I think that means the human's always in the loop, so it's not quite right. Agentic, I don't know what it means. In terms of like the components, you have a data pipeline, obviously. You have model training and evaluation, of course. You have integration, right? Either you got to make this in that system or you got to give them API so they can do it. You have to have the monitoring, and of course there has to be retraining. Those are the basic components of a system like this, and I think it's pretty standard. Next, we can talk a little bit about the models. So I would say one of the innovations of sort of like 2010s Google Translate was being able to just successfully launch languages one after another. It was very hard in those days. one of the things that we did differently was sort of supported multiple languages out of the box. I didn't want to have to do that again. It was very, very hard to launch each language, so we kind of wanted to support multiple languages out of the box. And so we did that. It was this idea that was, again, like kicking around in 2019. For whatever reason, Google and Microsoft didn't do it, and we as a startup just had to for economic reasons. And specifically custom private models for each customer that then supported all of their languages. So we did this from the get-go, and I'd say it's core to our company. And maybe why a company like ours was not built sooner. Like when you still had to do one model per language. I think Zavin and I were trying this, and it just wasn't realistic to do as a startup. To launch each language back when you needed a parser and you know, morphology and everything for every single language. We're foundation model agnostic. I mean, new ones keep coming out, right? You got to have a infra where you can swap them in. And then we're independent of the machine translation, right? So there's always this idea of like, okay, the machine translation model also has some kind of, you can always tease a confidence score out of it at decoding time, right? That has a lot of problems. In any case, we don't do that. So the customers are keeping Google Translate or Microsoft Translator or using OpenAI or whatever for generating the translation. Obviously, you got to have synthetic data generation to solve this problem. So you got to make up new examples that the model hasn't seen in the training data. And there have to be additional guardrails. Just models, just sort of classification alone is not enough. And we actually, I lied, we actually do two models. So we do one for verification, but we also do one for editing, so fixing translations that get rejected to see if we can maybe salvage a few more. And so what we do now is, okay, if it gets rejected by verification, then it goes to editing. Very important, then it comes back to verification, because it still might be wrong. And then if it's good, then it gets a second chance in life and maybe can still skip manual translation. And this kind of raises your ceiling. This means you can potentially, as generation improves, finally there's direct value. For every percentage, more or less, that generation improves, that it's right, you can actually directly create value because on average, you're able to approve most of those. Yeah, so there's a lot of problems we have not solved. Firstly, just like I mentioned, more acceleration. What I mean is better generation. If we can generate more translations that are good, that will directly mean that translation can be accelerated more now that we have verification in place. And we're really just scratching the surface in here. You would really be surprised how few translations are approved by human translators for these kind of high-value content types. So more access and coverage. Right now, we really work with some of the world's largest translation buyers, but it would be lovely to be able to give this. Translation is super fragmented. If we could give this to companies or people who don't have as much volume. The life cycle, what I hinted at, right? If you're approving 90% of the translations, like we are for some customers, you're almost like when you're standing on a tree and you're hacking it with an axe, right? You're kind of eating at the data that you need to train the next model, right? And so how do you deal with these life cycle questions, right? Again, it's not Kaggle. You have to think about the consequences, the impact of the rollout of your system. More efficient training and inference, right? This is, obviously there are huge costs involved here. Understanding, I made up a word here, data bardak, right? So the data comes in many forms from, across all these enterprises in a very bad shape, and somehow understanding that and making sense of that, and they cannot help you, you got to help them. Dealing with this is scalably is very important. And then a bunch of obvious stuff, right? You can always have bigger models. You can always use more context than we use. You can always do more dynamic synthetic data generation. So instead of generating data synthetically, even when most of it might not be that informative to the model, you kind of do more of a generator discriminator thing. And then voice, for example. We do only text, right? This is there's a whole frontier. We're so far away from being able to do this for all content types, for all modalities. Yeah, so with that, I'm happy to take your questions if you have any. And maybe, I guess Stefan can, he's Tamada.
Yeah, thank you, Adam. This was very insightful moment. Maybe if I may pass the first question, then I can ask the audience to ask. So one thing that interests me very much, I mean, you explained here that very clearly translation is not solved, but maybe a lot of people will think is already solved. And also in the beginning, you were very clear that you were a little bit disappointed with the big ones. So my question is, how do you see the future? Will the big ones eventually solve it? Or what is the reason why they don't solve it? Is it like an organizational problem that they don't have the resources, or is it not economical? And what can they do to solve it, and what does this also mean for you? Will they acquire you, or whatever?
So I'm a big fan of revealed preferences versus stated preferences. So how many of you think, you know, AI will solve translation in like 10 years, for example? Right. So for those of you who think that, do you have kids? If you do, would you tell them, would you say AI is just gonna, you tell the kid, you don't need to learn English because AI is gonna do it in 10 years. You can just go to Harvard and found companies and read about ML and everything just using Google Translate in 10 years? So you're saying that, but you don't believe it, right? And now we can talk about why. I think Paul Graham, right, the founder of Y Combinator, is not known as an ML mind, but he has a very underrated tweet, which I bookmarked from like 10 years ago, which was, the more interesting your message, the less autocorrect helps you. So before Google Translate, I was working at Android, so it's like you have this mobile input, right? It's basically a language model that's predicting the next word, but as soon as you try to say something that's not cliché or schablonchi, it all falls apart, right? Now, when you talk about this high-value content, the interesting content, it's always the stuff about new. What do we do? Farfetch, largest luxury fashion marketplace. They get 3,000 new products a day. Not old products, they get new products. People doing patent translation, they get patent new inventions, right? And so you fundamentally always have stuff that, besides being ambiguous, badly written, et cetera, is new. You have new viruses, et cetera, that these models haven't heard about. So I think that's why it is that it's not like it's not a frozen problem. It's a moving target. Yeah.
Thanks for the talk. I wanted to ask a thing about your editing pipeline. So you said we use a verifier, then like if it doesn't pass verification, we send it to the editing pipeline, then back to the verifier. So it essentially becomes a question of how much compute can I throw at the editing problem? And the more compute I throw, more or less, is there a scaling law? The more compute I throw with my verifier, the better the editor model becomes. Can you use it like essentially as an RL setup verifier? Are you planning to do something like that? Can you talk about it?
I would say if you're interested in that, you should, in working on something like that, you should come talk to me after the talk. We know each other very well, but there are limits. I think I was talking to right, Ani's here from London, and right, she's mixed up in finance, you know, and this is a little bit like more like finance, right? You're getting these text inputs, right? And then you need to make a decision. And in this case, it's again going back to, it's more like Stavka. Like you get, you know, if you get it right, you know, you create some value. If you get it wrong too much, somebody's going to be mad at you. You're going to lose everything, so to speak, right? Because the whole. And regarding your question, you get a few shots, but you don't get infinite shots. Just in terms of the resource constraints here. So we could do more shots than we're doing, but we can't do infinite shots. So because it's actually a pretty interesting optimization problem.
Is there any scaling law? Like so essentially, does using more compute to like do this verifier, like self-refinement loop work?
Absolutely, more candidates is better, absolutely.
Okay, thanks.
Actually, are there any untranslatable sentences from one language to another where the concept itself cannot be translated? And does it sort of affect your verifier? Does it sort of stop it?
Yes, right. So the question is, are there untranslatable segments? You know, actually, that's maybe an even better to answer to the will AI solve translation question. There are things that humans cannot translate, right? That's why we speak in different languages in different occasions, because we actually can't do it. It's very, very hard. Definitely. But the great thing when I switched from working on generation to working on verification is, if something's hard, impossible, it's the source input fault, just reject it. So it's amazingly relieving after working on generation for a few years.
Thanks.
Thank you very much for the lecture. That was really interesting. You mentioned about the quality requirements, that you need the quality to be less than 1% as human translated. Did you do any comparison between humans? Because different humans, even professionals, translate differently. So there should be some consistency, or we should need from the verificator, the generator or verification system to be in the same boundaries as humans.
Totally correct. Yeah, there are differences between humans, and there are more than that, actually. There's a few things going on there. Firstly, we're held to a higher standard. Secondly, when you have very low edit, when you have edit differences, you don't know. But if they were done by two different professional, human, validated translators, you think, okay, well, it's probably fine, right? There may be even 5% or 10% edit distance between the two of them. But in this case, you want to sleep at night. You're working at a scale, right? Our customers have dozens of languages and are doing tens of millions or even hundreds of millions of words a year. We can't go check everything. And so you need it, you know, it's kind of like, maybe if I go back to the self-driving car example, like I can't be having like almost accidents all the time that we need to look into if I'm running a fleet of these things. It has to be way tighter than that for people to adopt it, to sit in it, etc. Right? So, but yeah, and that I would almost consider that more of a sales argument, which is like going and proving to people that there's this much disagreement between two humans. But that's not why we do it. We have a very high bar, sort of, to make our day-to-day easier, so to speak.
Thank you for your talk. So you already mentioned that you work with limited number of languages, but I was wondering whether you work with low-resource languages, and if you do, if you have any kind of success in that field.
I guess define low resource language. So I don't know if any of you know Paco Guzman. So he was basically running ML research at Meta, and right there, you know, Meta is basically, right, they have the most sort of user adoption, right, of any platform, and so they had hundreds of languages, and he was behind no language left behind. And I asked him when we had him on in the Machine Translate meetup, where would you say like a low resource language is today versus like English, Spanish 15 years ago? Which one is better? He said the low resource language today, without a doubt, is better than English to Spanish 15 years ago. And so that would be my assessment. And so when thinking about low resource languages, I think you can always just say wherever we are now for the high resource languages is where we're going to be in a matter of time for the low resource languages. Right, and so we support 100 languages, but like kinetic, high and low resource chi. Inke hitsuneror, yera sunerorda. In barbara germanerov eti low resource language. It doesn't have a written system. It doesn't have data. It has only one machine translation engine that supports it, et cetera, right? And so, it's the situation there is getting better. Has gotten better, but it's not something that we get customer demand for, frankly speaking. Yeah. unfortunately for me. But the good news for you guys is Armenian is much higher.
So thanks for the talk. My question is mostly about the fact that like previously, here, yeah. So my question is that like previously we kind of used like various metrics for assessing the translation quality, like blur.
Yeah.
And these days we kind of moved to the model-based evaluation. My question is like very with respect to the verification, is how bad, for example, like taking some open source language or language model like Gwen. How bad is it for like verification, like out of the box? So I take the Gwen and just like directly use it to assess the translation quality. Yeah, and especially compared to like closed source models, for example, to GPT-4o, which from our experience was quite good at assessing the translation quality. So my question is like, what's your experience with open source versus closed model, yeah, like closed source models?
Yeah, I view models as commoditized, so it's a very similar thing to the low resource language question, which is like, you know, tomorrow's mini model is maybe as good as yesterday's big model, right? And so that's always like kind of a moving target. But I guess you can say that all of our customers have tried to first use GPT before they came to us and pay a lot of money, right? And so basically it doesn't work for the kind of quality that we're talking about, neither of them, and I would view them as very similar, like because they're commoditized. So I think that's it, right? All we have time for.